like, what our status is, and then something about the architecture and the mechanical overview. So we started somewhere in November 2013. About 20 ASML guys and ladies, and we are all work. We have one thing in common. We work for the company ASML. We have a normal job, 40 hours a week, and in our free time we try to do something with Robocop. So we work in ASML, but we also all have different jobs to do. Some guys are mechanical, some are software, some are in our factory. So it's all different skills, all different hobbies. But we have one common goal, and we try to be the world champion, which is a high goal, but that's okay. Why does ASML participate? It's an ASML project. Our management said, hey, let's join Robocop because it's fun. There are various reasons. One is to promote a multidisciplinary team building between colleagues. So we meet a lot of colleagues during meetings, colleagues of different disciplines, and this is a way to meet those colleagues outside your work environment, to get to know each other, and that helps you when you are doing your actual job, because you know each other in your free time, and you know better how people respond, and that helps the company to make better products. Of course, it's also personal development. For instance, you are a mechanical developer, but you want to do something else. That's very much possible within our company, but it's not always very easy. So this is a way that you can experiment with other things and with other branches, for instance with software or with integration or with project leadership or whatever. So you can learn, you can try it, and you can see whether it fits on you, and then later on you can use it in your company. And also experiment with various walls. If you are a designer, you can try to do what the architectural wall looks like and that kind of things. And of course it can be technical and non-technical, because building a robot is one thing, but there is also something about recruitment or facility management or branding, promotional kind of things, facility management, logistics, that kind of things, and we all have to do that as well. And I'm an engineer, so I have no clue how to do logistics kind of things, but it can be very much fun. So those things. Yeah, and for ASML as a company, it's also promotional fairs, schools get people enthusiastic for technical jobs. That's what ASML is always very eager to present, and also already on little kids, make them enthusiastic to go to study technical things and to come work for them. So this can help, and also potential contact with new employees, see what we are doing outside work. It's fun, join us. And the last thing is, of course, for us the most important thing, for enthusiasm, to have a lot of fun and to see each other work, and to see this robot start moving. And we just reached it last Thursday, that we have finally first movements of our robot, so we were very happy. So if you ever look for a job, come work for ASML, because it's a great company. No. Which by the way is, but that doesn't matter. Our organization, we have two main parts. We have a technical, non-technical part and a technical part, and I come to those in a few seconds. And on top we have our main sponsors are Jules Mary, Jan Franse, who you probably know. He's one of the initiators of this project. So for the non-technical, we have something about branding and the guys who made our logo. Facility management, you will see tomorrow. We have a venue, we share it with VDL, but we have someone responsible for it to make sure that there is heating and there is couches and tables and that kind of thing, so that coffee is still there, which is very important, because if you like coffee in the evening, that's tough. We have also a team that tries to recruit new people in our ASML organization, because it's all volunteer work. So you can join and you can leave within a month or within a week or whatever, and within 2 months, if you have too much stress on your job, if it's too demanding for you, then you say, sorry, I don't have the time for the next coming weeks or months. So then we have to find somebody else who step in your place, because work always has a first priority. And we try to, for the Robocop, we also would like to make progress. So we have guys recruiting in the huge pool that ASML has. That's not always easy. We have guys doing logistics, we have the group leads who try to align the different groups with each other, and we have someone keeping up our finance under control, because you can spend a lot of money, but someone has to report it and someone has to pay it. So that's about the non-technical. On our technical thing, we divided our robot in 8 functional projects, and each project delivers hardware, software, and electrical. So, for instance, you have the world sensing project, and that's responsible for the camera, for selecting the camera and selecting this is the frame rate I need, but also to make it interface with our computer and to make the software. So they really deliver the function. If you have the motion group, they really deliver the function driving, but also the ball handling and also the kicking. The hardware and the software, they deliver the function. So we have 8 functional groups, and each of those groups they consist of electronic guys, mechanical guys, software guys, and they intermix with each other. That's how we are set up. That's also how we set up our company, so we use that matrix. But we decided to use functional projects because the project then really knows what he's delivering. The motion team, they know how to deliver the wheels and also to connect it and to make the software make it work. And beside that, we have something that we call system engineering, and they try to align between the various projects what each project is developing, what are the key things to develop. Also try to have balancing between the projects and to do trade-off. If, for instance, you say, okay, we can solve this in hardware and software, then the system engineering guys try to balance what the least effort is and what the best benefits are between the projects, and they also try to look ahead, see what our next robot would look like, which at our point is very difficult because we barely have a working robot, so it's very difficult to look ahead. It's very easy to look ahead, but it's very difficult to see what are the weak points of our robots because we don't know them. So that's what our system engineering is doing. And on top we have our project lead. And next to that we have the ASML platform. It's still an old name, but we now bought a 5K turtle. And in the future we will try to develop our own. But then the first thing is that we get to know this 5K with the future. So that's Jeroen is head of that ASML platform future. Our status. So we had a nice plan in 2013. We would buy the 5K robots and we go to Brazil and we would learn a lot. That did not happen. So there was some, the hardware promised to deliver us by the end of 2013. And the basic software layers would be ready, and we only had to do the higher level software things and the strategy we call team play. We should implement those, and then we were ready to go. But the hardware was delivered late, and there were some issues with it. We required mechanical redesigns from the start. We did not anticipate on it, so we had not the right team in place, and that was difficult. And we also had some big issues with it, we had also a lot of issues with the software. It was not in the state that we expected it, and not on time. So we struggled with that, and I think the main call to not go to World Cup was that we faced a human safety issue with our shooter box. When we engaged it, we had a lot of sparks coming out of that box, so we considered that as not really safe. So that's why we said maybe we should not go, because we cannot only harm our team, but maybe also other robots when we crash into each other. So that's when we said let's skip Brazil and go for the next goal and make sure that the robot works. So we are now redesigning that shooter box and redesigning the electrical wiring and that kind of things. So at this moment our hardware is okay-ish, and we give it 5 or 6 out of 10, which is very good at the moment. At least the hardware is ready to play, and that's the first thing. We can learn. We can learn what the good things are, the bad things are, and then we can make improvements. You really have to go. At a certain moment, you say this is good enough, and we go and play with it, or we learn with the thing. And software integration is ongoing. The software is based on 5K. We split up in, what did you say, in March or in April or something?
I think so.
And we went our own part now, So we are redesigning some things which we don't understand, or sometimes it's very difficult to adapt software that you didn't write. So some things we are rewritten, some things we put on different locations, so that's what we are. And our target is still, we will be present in 2015. We have no idea in what shape, but we will be present. So we are really aiming for that. A few words on integration. We defined 3 main milestones, and they're all, this is the main milestone, that's one, and that's one. So the first is to have a full functional robot, which means that the robot is able to do everything you should do. So hardware-wise, electrical-wise, everything works. Then you don't have the software to control it, but hardware-wise, everything works, and there is no mistakes. It's not when the shooter box is enabling, is engaged, that you hit the ball handles or something. So that's the first major milestone, and everything is yellow, that means that we are working on it. Everything that's green means that it's done, so we have a lot of work to do. The second milestone is to have an autonomous robot, that's so that he's able to do at least some things autonomous, that we have some kind of strategy in place, and that the robot is able to make some decisions, not all of them yet, but some decisions to show that he's capable of doing that. And the last milestone is that you have a team of robots that's able to play a game. Maybe not a good game, but at least a game. And as you can see, that's all white, so yeah, we have a lot of things to go. So on our first milestone, because we are trying to finish that by the end of the year, and on Thursday we succeeded in the green driving milestone, so we were very happy that we were able to, via ROS, give commands to the robot, and that he was executing, giving a set point of speed and the timing, and he was actually performing it. So we were really happy, but that also gives you an impression where we are. So we are working now on the localization, the world model, path planning, that kind of things. We are working on it, but it's not finished yet. And the 2 major milestones of the major targets that we have now is obstacle avoidance, which is on the left. I'm too small. And dribbling, which is here. So we have to engage the ball handlers, make sure that the feed forward loop is there, that we can control the ball at any moment. And then we work towards the rest. So a long way ahead of us. 3 words about our software architecture. I'm not a software expert, so I try to explain. It's the software architecture from the Turtle 5K robot. But some here and there we changed some things. And for instance, for motion, it was the motion control was done in Oracles, but we changed it to a middle layer, and then to control the and the firmware and the middle layer, not the firmware, to control the hardware. It was much easier to set up. So we struggled a lot with the Oracles thing. We didn't have progress for I think for some months, and then we made the decision. Okay, we move it to a middle layer, and then within 2 weeks or something, we had very good results. So it was for us a good decision to do. For us it makes sense, but we have a simulator. We consider that as working, but of course we have to expand the functionality. But I think we also use it from the existing from TU or from the Turtle, and we decided what we want. The robot intelligence. So at this moment we think that each robot has his own CPU and drives his own world model and communicates that with each other. And the coach laptop, we think to use it only for the setting of the high-level targets, red box situations, that kind of things. And we will see in the future how it works. And we don't know if one ROS core can support that completely. And I think that's one of, during lunch you ask that kind of questions. So I'm not the expert, but there are some guys you should share your knowledge with us. We can ask your questions.
I have an opinion.
More in depth. So we have to experiment, and we have to see, because we simply don't know. We are really integrating our first our one robot, and then we have to say to the team we are not there yet. I think this is my last slide. It's the total 5K hardware, and there are some minor modifications, but it's that's what it is. What we have right now. Yeah. So, if you have questions, I try to answer them.
Have you ever considered not using ROS? I mean, I know that was actually given by you in a certain way, like the software was depending on ROS. So now the question is, what are multiple ROS cores? Is there also a question whether to use ROS or not?
I have no idea. If we considered it, I think we took it as granted that this is what the 5K is. If we see that there will be a lot of issues in the future, then maybe we take another decision.
Yeah. The thing with ROS, so I'm from a World Cup at home team, not the mid-sized league, but we
Yeah.
use ROS, but we use ROS because it was, given. Like, there was nothing else back then, or there was, but we weren't aware of.
Yeah.
And now I noticed that it would be nicer to not use ROS in some cases, but we're still stuck in it. So, our whole way of working is kind of depending on ROS. Every time ROS changes version, we have to change as well. So that's why I'm asking, because you guys are pretty fresh in it, so there's still